Hello everyone, and welcome back to a new video in programming the finite element method using MATLAB. Now in this video we're going to focus on generating the finite elements from nodes and see exactly what it means and how we do that. Now before we start, I want to mention that this is part of a bigger series about the finite element method, which I will be linking in the top right, and its separate playlist about the programming aspects only, which I will also be linking on the top right. And as per usual, I want to remind you that if you are a channel member, you have access to everything that is shown to you here in terms of code. But if you're not a channel member, then fear not, because every single line of code will be written in front of you. You can write along and you will have the exact same code as me. So with that being said, and without further ado, sit back, relax, and enjoy the show. Now here in the generation of the finite elements, I must treat the nodes and treat the bars. So here in our generation, I should call for object.create finite element method objects from str nodes. That's the first thing I need to do. And I also need to create FEMObjects from str lines. And if I have any plates, I would do the same thing. I would say object.create FEMObjects from str plates. But however, my scope is not going to cover plates. That's something I have done in Strado and would increase the efforts tenfold. And I think this is good enough to understand the basic principles of finite element. Now, of course, I see a yellow line here because those functions have never been defined before. So let's define them. Function, create FEMObjects from str nodes. That's a function I need. Of course, I pass in the controller object. And then another function that says create FEMObjects from str lines, which is the topic of other videos. Now we are here in the create FEMObjects from str nodes, meaning I'm going to cycle through the nodes and I'm going to create objects based on that. So first things first, I need to cycle through those nodes. So I say here for I equals from 1 to the length of the nodes that have been defined, object.str nodes. So I'm cycling through every single node, which means I need to pick out the nodes. I'm going to say here node equals object.str nodes at the ith index. So now I fished out my node. And this is an str node. So first of all, we need to generate something called the master FEM node. Because since I have a structural node, a master FEM node should correspond to it. Now I explained in details how the user inputted model corresponds to the FEM model behind the scenes, and that's part of that explanation. Take a look at that video if you want to see exactly what I mean by this. Now here, I need the controller to add me a FEM node. I still haven't touched that, and I haven't done anything with regard to an FEMnode system, so I need to do this very quickly. Now I have done this multiple times before. If I want to define a system, I need to define its ID, and I need to define its database. I need an ID storage system. I will call this FEM. Let's put it down so that it's a little bit more organized. FEMnode ID. This is equal to 0. And of course, in the storage system here, I'm going to say FEMNodes to store those finite element nodes. Now I need a system to define FEMNodes. So here I'll copy this entire thing because this defines nodes, and I can just use it to define FEMNodes and even check if I have duplicate nodes or not, because we have done this before in one of the previous videos, which I may be linking on the top right if I remember exactly what that video was. So here, this looks odd. Let's put here a region calling it str object definitions, and here another region at the end of it by saying here FEM object definitions. Okay, I'll paste that. Now this is of course the add str node. I don't want it to be add str node. I want it to be add FEM node. So now everything with str must be changed to FEM. So this is going to be FEM node. That is going to be FEM node. He will check if it exists. If it exists, he will give back the node that is existing. I should call them FEM nodes. Let's write FEM everywhere just to differentiate between every single one of those. And even the output I'm going to call FEM node. So yeah, that's a FEM node. So he checks for all the FEM nodes. If there is an existing overlapping FEM node, he will return it. Otherwise, he will have to create it. And when he creates it, he's going to check out for the node IDs. But this time, he's going to take the FEM node IDs to increment them. and he's going to declare a new FEMnode by calling the constructor of a FEMnode, right? I think that's the construct. Let me check if I messed it up. No, everything is fine. So that is indeed the constructor. We are constructing a new FEMnode and adding it to a storage system. I need to be very careful not to blunder any of those symbols. So we added the ability to define a FEMnode, and that is something we're gonna do. So let's take this one and use it now. So here, during my efforts in creating, I'm still in the create FEM object from strnode. This is in the controller. Now here we are going to create the master FEMnode. Remember, we stopped here because for every single strnode, we are going to create a master FEMnode for that. So here, I'm going to basically say master FEMnode, or just master node, or maybe I should precursor with FEM master node. Let's precursor with FEM. This equals the object, which is the controller, dot add FEMnode, right? And now I need an ID. Oh, I forgot. Wait, no, I don't need an ID because the ID system is declared inside the controller. That's the beauty of it. Now it needs the X and Y and Z. Well, I am going to render this str model into the FEM space, meaning it will have the same X, Y, and Z. So I will call node.x, node.y, and node.z. So now I am creating a master FEMnode at the exact location. Now here, there are some other things I need to declare. First of all, the FEMnode must know its str node. And something that I have not done before is that the str node must know its FEMnode. So the picture of the structural elements must always be aware of its corresponding FEM element, and vice versa is true. The FEM elements must always know which of the str object it corresponds to. It's a two-way binary relationship, meaning that in the node, before I continue anything, I should say node dot corresponding FEMnode. So the node should know what its corresponding FEMnode is, and it's going to be FEM master node. Now this will cause an error if I run it. Why would it cause an error if I run it? Because I have never declared this before in the node. Let me show you. If you go to strnode and open it, you will see that those are the only things that are declared. So here I need to say corresponding FEMnode as a property so that I can access it in the str controller. Otherwise, I will get an error when I do that. So now in the str node, there exists the corresponding FEMnode, which means now that I can assign the FEM master node that I have defined into the corresponding FEMnode, because later I'm going to read from the master node and give the values to the node to show as reactions, for example. So this is FEM master node. Now here we need to do some extra stuff. FEM master node dot is master node. This is equals to true because I told you before that there are some things we need to declare. Let me explain to you. This is the FEM node. Those are the things we need to declare. We have is master node, is slave node, is support node, slave FEM, master FEM, and corresponding. So let's declare them one by one if we can. In the str controller, I'm saying here, I defined my FEM master node and I assigned it to my str node. And now let's continue definition of our master node. So since it's a master node, so the is master node is going to be true. I need to double check if he understands what true is. So let me write true in the console and I get a logical one. So yes, it understands true. I'm going to call FEM master node dot is support node, and that's a glaring false because this is the mirror of the node, not the mirror of the support. Later, we're going to add a support node and then we will put the flag as true. For now, this master node is not the one that has the support, so it is a false for the support. Furthermore, FEM master node dot is slave node, that's false again, because it's a master node, so it's impossible to be a slave node. I know this is redundant. I could check the not of it, but I will keep it. There are multiple things I need to declare. I forgot what those are. Let me see. FEM master node dot, I think there is something called slave node. Let me just check if I forgot anything. Let me copy those things, Control C. and push the Control V button here just to make sure I didn't forget anything. So this is master node, has been assigned. I can delete this, just a reminder for myself. Is slave node, I have assigned it. Is support node has been assigned. Slave FEM node so far is nothing. So far. This might change, but for now, it's nothing. Then FEM master node, that is definitely nothing, because a master node cannot have another node for its master. This is usually filled if we have a slave node, and this is filled if it is a slave node, but it's not, so it's null, empty. And also, finally, we have the corresponding str node that needs to be filled. I'll go here, FEM master node dot corresponding str node. This equals the node, which we started with from the str nodes. Fantastic. I finished the definition of my FEM master nodes. Now, I need to add some stuff. I need to deal with the supports, but that is something I will do for later. What I will do for now is I will start plotting two plots in the viewer. I will start plotting something called the structural plot and something called the FEM plot. Now, how do I do this? In the viewer, we have here a figure, okay? So I'm going to use subplot to have two plots. So when the render is declared, I'm going to first of all preface this. Okay, this doesn't make any sense. Let me just improve this. So this is the render command that gets called when you call for the rendering. So let's play with it a little bit. Now here, I'm going to split this rendering into two renders. I will say here, object.render structure and object.render. Wait, I need the controller for this because I need to get out the nodes for the controller. And render FEM, Finite Element Method model. And here I also need the controller. So now I'm going to plot two plots. I'm going to take this stuff and I'm going to refactor it to become this function. So here I need another function. Function, render, structure. It takes in the object and it takes in the controller. And of course here, I'm going to copy this entire dude and paste it here. So far, so good. Now, I need another one. But before I do, I need to use the command subplot to let the plot be plotted on one half of the figure. So I'm going to say, I want to use a subplot. I want to have one row of figures, two columns of figures, and we are talking about figure number one. So all what you see here should be done in figure number one. Now I need another function. I call this function render FEM model. And here I'm going to pass in the object with the viewer and the controller. And now I'm going to do the same thing, but I will render it differently. I will go here, control paste. This is going to be subplot 2. I'm going to render, for now, the FEMNodes, which means I will fish them out, FEM, and I will call render FEMnode, which means now, of course, I need to target FEMnode, which means now I need the function for that. So I'll go to my render node function, I'll copy this entire dude, paste it, and I think I should organize it better like this, but I'll keep it for now. Render FEMnode, okay? Now this is, by the way, a FEMnode, not node. I'll copy this, I'll paste it everywhere, and let's change the color. Let's give it a, I don't know what color we can use. Yellow, maybe? Maybe yellow. I don't know. You know what? Just keep it the same color. Okay? Now to differentiate between them, how can I differentiate? Let's see. I can go here and give it a title and say here, structural model. And there I can give it a title and call it, well, let me just copy the axis equal thing. I can give it a title here in the render FEM stuff. There we go. And here I can give it a title and call it FEM model. Okay, so let's see if this works. What I have done is at least I created for every str node in the controller, I created a corresponding FEM node. And now in the viewer, I split the view into two views, one of them for the structural system that the user is using, and one of them for the behind-the-scenes FEM model. So let's run, and of course, all the bugs of the world should come. Oh, there are no bugs, it seems. I am extremely surprised. Now the figure came out. This is the structural model on the left, and that's the FEM model. Of course, the FEM model is missing a ton of things because we haven't done anything so far. We just put the nodes. And you know, for funsies, I am going to change a little bit in my sample frame. I am gonna re-add line 4 and re-add node 5 and 6. Remember those in the previous videos when we tried to check out the intersection of those. So I'm re-adding node 5 and 6 and re-adding line 4. You can pause the video and go to your sample frame and add those if you want. And I'll go back to main and run just to see the cute intersection and the FEM nodes that are generated. So everything is supposed to be fine. The only way to know this is to check out the drawing. And indeed, you can see in the structural model, I have nodes, str nodes, and the FEM model, the only thing I have is I have defined some nodes. I still haven't touched any members, but this comes for later. We are constructing the FEM model based on the structural model. So it's only gonna get more interesting by every single video. So yeah, that's everything I wanted to talk about today. I hope you enjoyed. And in the end, I want to give a model-sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as the support to the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and I will catch you in the next video. Bye bye.